GM, my fellow Allorians. Welcome back to Allora DevPills. In previous tutorials, we went over how to create an inference worker that would generate inferences for a given cryptocurrency on a cadence and have those inferences be submitted to the Allora network. Today, we're going to talk about a different participant of the Allora network known as the Reputer. Reputers provide the ground truth for a topic. Given that we're submitting all these inferences from different inference workers on the network needs to figure out which inferences are better than others. And the only way the network can do that is by getting the ground truth and comparing the ground truth retroactively with all of the workers that are submitting inferences to score those workers. Reputers are the network participant that submits the ground truth. So if I have a topic that's goal is to predict the price of Ethereum every 10 minutes, at the beginning of a 10-minute period, or epoch as we like to call it, workers are going to submit inferences. Those inferences are going to be stored on-chain on the network, and at the end of the 10 minutes, the network will request reputers to submit the ground truth. Once the ground truth is submitted, that ground truth will be compared with the inferences produced by said workers. If worker A has a prediction of 2610 for the price of Ethereum and worker B has a prediction of 2620 and the actual ground truth after 10 minutes was 2612, I want to score worker A higher than worker B and create a higher weight on it. In future epochs, worker A is weighted more and we can get a more accurate network-wide inference that's produced at the end of an epoch. The entire goal of the network is to produce the best possible inference on an epoch to epoch basis. It makes sense that we're going to give a higher weight to worker A compared to worker B and continue to iterate on that every epoch. If worker B starts producing better inferences than worker A on a consistent basis, then worker B will start to get assigned a higher weight from that point on. This is all in relation to the ground truth, which is why reputers are such an important part of the network. So now that we've explained what a reputer is and its role as a network participant, we're going to deploy a reputer to the network on Allora's testnet and have it submit the ground truth. First things first, when we go through these tutorials, we want to go straight to the documentation as it has the most simple and meaningful explanation on how to deploy a reputer. Now that we have the documentation up, let's open up Visual Studio Code and start coding. So I got a new Visual Studio Code editor up and running here. I'm going to clone the Git repository. Git repository here is the coin prediction reputer. Copy that and clone Git repository in Visual Studio Code. If you don't have Visual Studio Code, always feel free to copy the entire code line and paste it into your terminal and copy that coin prediction reputer as needed. So let's select this repository destination and open up the cloned repository. All right, so now that I got my repository up and running in Visual Studio Code, I'm going to copy over my config.example.json file into a config.json file. So I'll run cp config.example.json, config.json, and create a config.json file, which I can open and change accordingly. Three things I want to change, like we discussed in the worker video, are the address key name, the address restore mnemonic, and the node RPC. So I'm going to copy over my test key and restore mnemonic from previous tutorial. And I'm going to use the testnet node RPC for the Allora network. One thing to note here is that submit TX is set to false by default, which means this is a testing environment. You need to set submit TX to true if you want to actually submit transactions to the network. So we're going to do that now. Before I run my node, I just want to run through a couple of things in app.py to show you where the data is being grabbed from and how it's being coagulated into the network. So if I open up app.py here, you'll find an update price function. And inside that update price function, on line 57, you'll see a construction of the CoinGecko API URL. This CoinGecko API URL is taking the current price of the token that you're using, in our case ETH, compared to USD, and it's storing that price inside a SQL database. That SQL database will hold all of the different ground truths for a given reputer, and then upload those ground truths to the network when the network calls for the ground truth. So now that we kind of understand what's going on beyond the scenes, let's deploy our reputer to the network and start submitting transactions. So first things first, I'm going to run chmod here, init config, and load my config.json into my environment. Finally, I'm going to run Docker Compose, and I'm going to build my Reputer so that it starts submitting the ground truth to the network. Now that we've loaded our config file into our environment variable, the last step is to run Docker and spin up our node. One thing I wanted to point out before we do this is the Allora API. We use the Allora API in app.py over here as a validator API URL. This validator API URL is going to query the block height, and that block height is going to tell your Reputer which block to submit the ground truth at. You need to keep this in mind and make sure that when we convert to another network, like a new testnet or a new mainnet with a different API URL, you're going to need to change your validator API URL here, as well as in your docker compose.yml file here. Right now, we have the Allora API.testnet.allora.network for the current testnet that we're using. And when we switch over to a new network and we propagate to the community that a new API URL has been created, you'll need to change that in both of these places. So just pointing that out. Let's run Docker Compose and see if we can get this thing working. My Reputer node was already registered, so it's skipped. Now we have to look for a successful transaction, which we have right here. So this Reputer data was sent to the chain successfully, a transaction hash comes back, and a message showing success comes as well. So now we can conclude this tutorial. Please leave any feedback in the comments below. I hope you found this useful, and in the next tutorial, we'll go over topic creation and creating an entire stack for yourself. Spinning up a worker, spinning up a Reputer, and spinning up a forecaster, and making the entire network work in your favor for a specific topic. Thank you.